Hi guys, and welcome to our first video of the week. This will be our last week talking about quadratics, and we're gonna first talk about solving unique quadratics part 1. And you have an assignment that goes along with this video. Make sure that you are watching the video and then completing the assignment. Some of you are doing assignments and the answers aren't really matching what we've talked about. So make sure that you're paying attention to those things. Okay, so we're gonna just do a few examples, and I'm actually working on the same worksheet that your assignment is on. I am actually doing some different questions than what you will have assigned. Okay, so the first one I'm gonna start with looks like this. And we can still solve quadratics even if we're not given numbers, even if we're given variables. So the first thing we're going to take a look at here is, how do I solve for x? And basically you have three options. You have factoring, not going to do me any good because I've got q. You've got completing the square, which is a fine way to do it, just a little long, or you've got the quadratic formula. And I think the quadratic formula in this case, and actually in a few of the examples that we do today, will actually serve a really good purpose. So if I remember what my quadratic formula is, I'm going to write that down. And I need to go ahead, and in my equation, I need to go ahead and identify A, B, and C. A is 4, B is -12, and C in this case is Q. So remember, your first step when you're dealing with the quadratic formula is to literally just fill it out exactly how you see it. Okay, there, I filled it out. Now I'm going to follow some order of operations, and I'm just going to simplify this. So I have 12 plus or minus the square root of 144 minus 16q all over 8. Looks a little weird. You're kind of saying there's nothing else we can do because of that q. And I'm going to say we need to do some manipulations of this problem in order to simplify it a little bit further. So if I go ahead and I look at this and I realize 144 and 16, they have a common factor. I'm going to factor out what's common. So in this case, 16. And that would leave me with 9 minus q. And this is all over 8. So now, because this is separated by a multiplication sign, I can do the square root of that part. So I have 12 plus or minus 4 square root of 9 minus q over 8. Now remember, we can't take this any further because you can only reduce radicals when the operation underneath the radical is multiplication. This operation is subtraction, so that's the way it stays. So now when I look at this, I realize 12, 4, and 8. They can all be reduced by the same number, and that in this case would be 4. So x would equal 3 plus or minus the square root of 9 minus q all over 2. So there's my answer. That's what I was asked to do. I was asked to solve. This is as best as I can solve this answer. So I'm done. All right. We're going to do one more example like this one. And then we're going to take a look at two different ones. So in this one, I actually have two different letters, M and N. Okay, x is the variable. And I realize that I'm not equal to 0, and I need to solve it for x. So remember, anytime we're solving a quadratic, we go ahead and we make sure our quadratic equals 0. So that should be our first step. So I'm just going to go ahead and make this equal to 0. And then when I look here, I realize that these both have x's. And since when I think about what a quadratic looks like, I've got something x squared, and then something to the x, and then some number, I can go ahead and rewrite this one like this. It's kind of like I've factored out the x. All right, I'm dealing with variables, or I'm dealing with these letters. I've got to solve it. Factoring isn't going to really serve. Well, factoring, you could maybe do this one by factoring. That would be an interesting way to do it. I think you could do it by factoring. But if you're not sure, then definitely using the quadratic formula. So I'm going to have to go to a new page. And I'm going to write that one at the top of here. And we're going to go ahead and we're going to identify which numbers represent A, B, and C. So A in this case is 1, B is m minus n, and C is negative mn. Using the quadratic formula, I probably have this memorized at this point. So now we'll just fill it out the way I see it. Now this is where, if you're good at multiplying things, and this is all just algebra, is kind of all we're doing now, because we're going to manipulate this problem so that we can get it in the simplest form possible. And a lot of different ways to go about this. And probably one of the first things I'm going to do is I'm going to take care of this negative. So I'm going to say, okay, x is going to be negative m plus n, plus or minus the square root of. Okay, I've got this stuff to deal with. So if you guys remember m minus n squared, hopefully you remember that. I'm going to kind of do some scratch work down here. M minus n squared, remember, means m minus n times m minus n. We should be pros at multiplying binomials. You might even be able to multiply it in your head. Totally fine if you can. Minus mn plus n squared. Okay, so this guy turned into this. M squared minus 2mn plus n squared. Then I realized I gotta multiply this thing right here. It's gonna be plus 4mn. And this is all over 2. And you're like, well, I don't know if this looks any better. And I'm gonna say, yes, some cool stuff's gonna happen here. So I'm gonna continue on down, and this is gonna be negative m plus n, plus or minus the square root of. If I look at this, those can combine together, right? So m squared plus 2mn plus n squared all over 2. And maybe you're looking at this and you totally see what's happening right now, or maybe you're not sure. And basically, I'm concerned with stuff under this radical. And if I look at this, I realize I can factor that. And interestingly enough, when I factor that, it's going to factor into something that looks like this, which is a relief, because this is going to become the square root of m plus n quantity squared all over 2. And you know how to take the square root of that. So x is going to be negative m plus n plus or minus m plus n, because the square root of m plus n squared is m plus n. All right. Now this is where you guys, for some reason, are ignoring the fact that I have 2 different solutions here. One with a plus sign and one with a minus sign. And I need to write them as 2 different solutions. One with a plus sign, or one with a minus sign. All right, now when I look at these, I realize these cancel, and this is going to give me 2n over 2, which is just n. Kind of a nice answer. All right. Then if I go over here and I distribute that negative, I'm going to end up with something like this, and I realize, wait a second, negative 2m over 2, which is just negative m. So really my solutions here are going to look something like that. So these are kind of just some unique algebra intensive solving quadratics. There are 2 more for this video that I'd like to do, and then the second video for this week is actually pretty short and pretty quick. So, so by all means, at any point in time, you guys need to pause this video or go back, please do. Okay, so we're gonna take a look at these last 2 examples, and these are still solving quadratics, and these quadratics are kind of looking a little bit different. Okay, this one's pretty easy and pretty straightforward. Remember, to solve a quadratic, you must first equal 0. So minus 29x squared. You're like, okay, piece of cake. But wait a second, quadratics have squareds, not fourths. Yeah, so this is kind of like a secret quadratic. And back when we did factoring, we talked about how to factor these. And so that should be pretty straightforward for you. You should be able to identify what times what is going to give me 100, that's going to add or subtract to give me 9. And hopefully, really, because I feel like we've done this a million times this year, you all know you get 25 and 4, right? 25 times 4 give me 100. 25 and 4 can give me negative 29 as long as they're both 0. So now when I'm looking at this and I realize, am I in fact done? No, I'm not done, because I realize I have the difference in 2 squares, and we've factored that before. We know we have x plus 5 and x minus 5. And then we know we have x plus 2 and x minus 2. So now each one of these is going to be a solution. So I'm just really setting this up like this. So this one, x is going to be negative 5. This is going to be 5. X is going to be negative 2. X is going to be 2. So when I look at my answers here, here's my solutions to this polynomial, which is like a secret quadratic, or in this case, unique. Okay, last one, and then our video's over. Like I said, this first video is long. Our second video this week is pretty short. Okay, so we're gonna take a look at this one. And you're like, wait a second, not a quadratic, but it's like one of these secret quadratics. We can still factor this. We know what times what's going to give me 8. That's going to add or subtract to give me 7. That should be pretty straightforward. Negative 8, positive 1. And you're like, that looks like something familiar. Go back to that first, second, unit 2b when we talked about factoring. These are the sum and difference of 2 cubes. So this one's going to have a little parenthesis and a big parenthesis, plus, minus, plus. Hopefully you've remembered something. This one's the same thing, little parenthesis, big parenthesis, and this one's going to be minus, plus, plus. And this is a 2x squared, 2x, and 4. This is all review, factoring, all review. Okay, now I've got to solve. And I realize anytime these come from a cube, you cannot factor them, and they're quadratics. So if it's a quadratic I cannot factor, I'll be using the quadratic formula. Well, these are pretty easy. X plus 1 equals 0. So x is negative 1. Okay, that's straightforward. This one, the same thing. X equals 2. All right, those are easy. Now these guys, quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. First step for quadratic formula, always stick in all the information. So x is going to be 1 plus or minus the square root of 1 minus 4 all over 2. So it's going to be 1 plus or minus the square root of negative 3 over 2. Hopefully you've realized, wait a second, this is the square root of 3i over 2. All right. that's really not so bad. Now I gotta do the same thing over here. So x is gonna be negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm just simplifying with all of these things. So x in this case is going to be the square root of negative 12 over 2. So negative 2 plus or minus the square root of 12i over 2. Hopefully you have not forgotten things about reducing radicals. So you now know, I might not have enough room, I'm going to try to squeeze this up here, that x is going to equal negative 2 plus or minus 2 squared root of 3i over 2. Then you realize, hey, I can reduce that. So now when I look at my solutions, these, I'm sorry guys, that this is definitely a homemade movie. Nothing professional going on here. Don't claim to be. These are all my solutions. All right, so give this assignment and give this homework a try. Next video should be really short. Thanks for sticking this out with me. Please message me with comments or email me whether you need help or whether something with the video didn't go right. Okay, thanks guys.